Yeah, he jumped in there earlier. He had some issues with his headset. So he's back and he's going to join us tonight in the discussions. Live chat is open. So any questions, comments for the panel tonight, please uh, feel free to type it in the chat and we'll try to answer your questions. So I guess we'll start with our little lady down there in the right corner, Lulu.
Hi Ben, how are you? Glad to see you that you're back and in action and everything. All right. So let me get back to let me start with my thing. Earlier today on Nathan, he was talking about his 0 point. So I was trying to make a comment on there, but I don't think people understood. It's called the Berry
Hello,
Center.
everybody.
Hi Nate. Hi Ben.
Hello, Ben.
Hey, Nathan. Hey, Lulu. Hey, Mike. How
Hi.
you
How
guys
are you?
doing? Good to see everybody.
Good to see you.
Yeah, we're just starting with Lulu tonight, and we're just going to kind of do a roundtable of what we've been working on and researching, and we'll just take it from there. Sorry
Awesome.
about that, Lulu.
No worries. But I wanted to go back to my Berry Center definition. Because okay, perfect. Okay, so our universe revolve, like its trajectory goes to a point that's a little bit before the sun, and it creates a like vacuum zone, a gravitational point, 0 point, like where all the energy, we don't see it, but it's called the Berry Center point. And our universe, all with all its planets, all rotation, follow that point in space. And so there is, I don't know how what the science is, but it makes sense. Like if a lot of energy is put into one point, it creates a heavy like the heaviest part, like a black hole. And so it would be like the 0 point. But this thing looks like more like this. Last time I was trying to show it to you guys, trying to explain like how the point works, but it looks like this, of course, with a little bit more things that are, creating like a whirlpool, in that center. But it does an up and it does a down. So you have like a wave function right there, and this thing, like leads our solar system. It's like the coolest thing. So do search it. It's the legal or the definition to it on Wikipedia. It says. In astronomy, the Berry Center is the center of mass of two or more bodies that orbit one another, and is the point. Oh, come on. Where everything converges. So look it up. I think this is very relevant in how we measure, space and time and energy and, our the speed, of our solar system. So
So it's kind of like the yin and the yang, and it's swirling.
from what I read and I understood, it's not the yin and the yang, but rather of a point that our solar system follows. It's an invisible point, and it falls by because it's denser, and it's right before the sun's, wherever the sun is moving. So I don't know, this is my theory. When we see a double sun or double horizon, maybe that's what we're seeing, that point, because it's a little bit ahead of the sun. And so I don't know, because we're always in constant motion. We're not, there's a lot of orbits that we do, and a lot of directions that, like where the magnetic field goes, we align with that. And so that point, maybe this is what we see sometimes as a double helix, double horizon. It's that point, it's the Berry Center. Yeah.
Cool. Interesting.
I'm curious, is it a virtual point and it's the center of mass where there's two outside objects to it? Or is it an actual, like a black hole event, a horizon in the center?
Or how about even like a gyroscopic effect?
Yeah, well, that's what I mean. Is it like
I don't
the
know.
center of mass doesn't have to be an actual physical point? It just has to be where everything swirls around. You know what I mean?
I don't think this swirls around, like it swirls around it. The point is it follows it. It's not, it doesn't orbit around it. You know, it's a point that the whole solar system like moves towards. And so it's like an indentation in the space of like you know, the fabric of space. And
Mhm.
so it's like,
How about
okay,
a curvature of space?
yeah, something like, I mean, if this is like, if we're going this way, you know, in space, it creates like a dip, you know, like so the planets have to go, but it's a moving one. It's a constant moving one. That dip is always moving before, you know, like the sun.
So it's
And
like
so
a
the sun's
dipole with
having
the
to follow
planets
it.
acting like the electrons, pretty
Yeah,
much.
it has to follow it, you know,
Hmm.
like I don't know how to explain it better than that. If let's say if it's tilting space time, and so the sun's having to move towards it. It's like if you're going down and you know a downhill, or you know, it's like that. So it's forcing the sun to move towards it,
Toward
and
an
then of
area
course,
of low potential, an area of high potential going to an area of low potential, you're saying.
yeah, maybe, but you know that's how I understood it.
That's
Interesting.
cool. Like a vortex, just vortexing.
Yeah.
I mean,
Yeah.
I wonder like if that is, you know, what is attracting things, you know, in our solar system, because it's a point of energy, you know, like if energy can come out, go in, energy can come out, you know.
Mm-hmm.
Yeah, so I
I'm
don't
gonna
know
have to
why it's
look
not
into that.
talked, like it's, I don't know why they don't talk about it in physics. It's like I really had to dig for it, and the second that I started digging, you know, uh, uh with that term, all of a sudden within a few days there's like I don't know how many videos online about it. Like, man, like every time every time like I search something, like like all of a sudden like there's like I don't know hundreds of sightings, you know, like they start to cite the same because I go back to it and I'm like, dude, I was like maybe one or two, or you know, sometimes the first person on that. But you know, like when I go back to reference it, I see like in such a short time, it feels like, you know, my browsing history, like somebody's following it and following that data tree, and they're using it, you know.
Google does that.
Maybe.
Google does it to recommend shoes for you. Anything that you look up,
Yeah.
it actually will bring you to those things and all the ads to you.
Yeah. Yeah, for sure. But Lulu, you're more into the astrophysics, not just physics, astrophysics.
Yeah, because it makes more sense to me. You know, when we talk about the electrical stuff, I love it, but I
But
like to
it's all related. It's all
exactly.
related.
Yeah. So
Um, like the electric universe, right? Trevor Constable. Yeah, I think Trevor Constable was pretty right on the money in his theories, and it all relates to astrophysics as well.
Well,
Right?
you don't have anything in the universe without electricity. I'm sorry, it doesn't work.
That's right.
there's the hydrogen
It's
frequency line. There's so many atoms of hydrogen in every, you know, so many cubic
and what does
meters of
hydrogen
space.
produce? Hydrogen
Exactly.
creates electricity,
Hmm. They
right?
don't
It's
tell you about
fluid.
that, you know, stuff, but
That's right.
yeah.
Hydrogen is one of the most fundamental noble gases in the universe, but it's also responsible for creating electricity, especially in
Hmm.
a battery scenario. Yeah. Without the
You
hydrogen,
know,
you don't
like
get current.
they don't teach you this, and the other day I was actually searching it as well. The layers of atmosphere, the like the higher you go, the more of the less mass atoms there are, and a lot of these elements could be used as fuel right then and there, because there's, you know, it kind of filters itself out, you know, like with density of the atoms. on how. So like the higher you go, like you've got hydrogen, heliums, you've got the lighter elements. All of these could be like right then and there as you're going up, you could extract these things and use them as fuel, just by creating like a vacuum chamber in a rocket. Like it automatically will just suck it in without, there's no effort, like it fills the tanks before on its way up. They, there's so many cool ideas, but people have to understand or know or want to know the science, so they know where to apply it or how to apply it or where it needs to be applied. You have to know the science of it,
Yeah.
Yeah, all these gases and electricity and all these forces, magnetism, heavy side component, electrostatics, all this stuff, it makes our universe the way it works.
Absolutely.
And they're all interconnected with each other. One could be the creator of another and vice versa, you know.
Well, I
So
mean, they say when somebody has a good idea, just the mere thought of it, others could think of it at the same time, because it goes into this shared field, of a potential. And so when people decide to pull that information or, start to search to prove their, you know, what they know, like all of a sudden our world, like you'd see two, three people doing it at the same time. It's like, how did they come up with that? It's just because we're all connected one way or another. They say we're all about 6 degrees of, I don't know, like connections to each other. 6 people, like it will take 6 people for that would connect two people that don't know each other globally. Just like you meet somebody and that somebody will know somebody, but like if you follow the chain, it would be like 6 people, and
It's a
any two
common
people could be
phenomenon in
connected.
the history of science. One inventor independently discovers something or comes up with a theory that's identical to somebody else at the same time, or
Yeah.
multiple people. And it's like nature the universe almost wants to will it into existence.
Yeah. It's like I think it would be like point to point. Like 1 point is 1 dimension, 2 point is 2 dimension, 3 point is 4 point, and so the more people you have an idea, the more it takes shape with depth. But one person is just 1 point. 2 people, it's a connection. 3 people, it's a field of ideas. 4, you have stability, like, and so forth.
Well, that's a
It's
good point.
geometry.
You have to have multiple points to create multiple dimensions. So it's interesting analogy.
Yeah, same thing with people. I mean,
Mhm.
yeah,
we're all connected to that too. Everybody
absolutely.
thinks that we're not connected to it, but we are.
It'd be interesting to find the harmonic between the people if they're the same.
Mhm.
Yeah, some people
Yeah.
probably resonate better with others.
Yeah.
It's interesting. Yeah, everybody has their own electromagnetic field that they're producing.
Well, the aura, right? People
Mhm.
have these auras. I was watching a few videos actually this week with David Sarita, and he's working on these energy pendants that you wear, and they give off a little bit of voltage, but they resonate with your body, and they're really, really cool. Those some of them put out quite a bit of power. Well, not like hundreds of volts, but enough voltage to have interaction with your body. So he's been around forever too, David Sarita. Yeah.
It's pretty cool.
So Mike, any new interesting anomalies in the skies with your pyramid?
You know what? Since the cold weather has hit, I haven't really been able to get outside and do anything without freezing to death. Right? And batteries, don't really last too long in the cold. So I'm going to have to leave that for the spring. But I'm working on the new Renegade, and I'll be working on that project for the next few months because of the weather. It's going to be hard to get out there and get stuff done. But I got all the plans. I know what I got to do. So as soon as I get a couple of really good days, I can go out and get the build done. Right. So.
Ooh, a Renegade 2.0?
3.0.
3.0.
Renegade. Yeah.
Nice.
Because it's gonna have a 2,000 watt inverter hooked up to it, The wheels can be spinning in a vacuum locked chamber, so there's going to be very little air friction. It's also going to be a maglev as well. So hopefully the spin on it will be very, very efficient. I'll get it up to a decent RPM and might be able to spin for hopefully a week on its own without any interference.
Yeah, especially with maglev bearings.
Yeah. So it's going to be
That's awesome.
maglev. It's going to be in the vacuum chamber. Yeah, it's going to have a couple of new features to it that all the other machines don't have. The piezoelectrics are still a big part of the machine. So I've been doing some research on piezoelectrics, and like it's the only solid state over unity device that I actually know is real, is a piezoelectric.
Mm-hmm.
Because you're getting more than double the power coming out when you put one impulse of high voltage to it. You're going to get more than double back, and it's very consistent. So yeah, another guy I've been really kind of backtracking on is Joseph Newman. I don't know if our panels really looked into Joseph Newman, but he refers how the electron moves around the inductor the same way as a gyroscope.
And you
So
put
if you know-
the piezoelectric on the load, or the parallel with the load?
You basically short out the coil with the piezo.
Oh, you short out the coil. Okay.
You basically short out the coil using the piezo. So as soon as
Interesting.
you release the power, you get the inductive reactance type scenario happen in the coil, the back spike or the back EMF. That hits the piezo. So like most piezos, when you put physical pressure on a piezo, it gives you power. There's other ones you bend, it'll give you power. I have the novel way of hitting it with power. If I hit it with power, does it give me something back? And
Right.
lo and behold, it gave me double what I put in. And I'm like, whoa, what's going on?
Wow.
And that's where I realized I had something. And still, I'm looking online. Everybody's had a blind eye to it. Nobody's doing it. Still, nobody is doing it.
Yeah, that's crazy.
That's showing on YouTube. And there's a lot of people doing pulse motors on YouTube. Not one of them I've seen use a piezo transducer. Not one.
Well, I think that's just proof, Mike, that this really is the League of Extraordinary Inventors here. We got a bunch of remarkable people on this show.
See, the thing is, like some people have their way of thinking, and they don't look outside of the box and see what other people are doing to cross-reference what they're doing. You know what I mean? And they just don't do it. Like I had, I think 2 people in the last 5 years that I've corresponded in emails where they've actually done what I've been working on. And they go, holy cow, man, it works. And I go, what am I trying to tell everybody for the last 5 years? It works. But most people don't do it. It's like it's right there.
My jewel thief does it. I have a piezo hooked to it.
Yeah.
And it doubles it.
Yeah. Interesting. How did you hook it up to your jewel thief, Nathan?
It was just, my gravity flyer on the very top, it has the piezo. It basically goes through I'm going to say this. It's emitting the sound, right? Because it's an emitter and it takes in the sound. So I have a small toroid in there, and as soon as it comes into it, it gives it the frequency, and then you turn it off for a second, and it'll blast it.
Oh, wow.
Speaking of which, I was using my transducer one Saturday afternoon, and I was pulsing the hell out of it, putting a lot of just pulsing the crap out of the thing. I came back a week later. Thing was set. All the power's been off for an entire week. I went to grab it. Boom! I got friggin' zapped.
Oh, wow. So it held...
It's for a
It held
week.
the capacitance.
Oh my
week.
God, that's crazy, right? Yeah. How long does a capacitor usually hold a charge for?
They bleed out. Usually they bleed out over, a day or whatever. This thing held it for a week, and
Wow.
friggin' I zapped myself the next weekend when I touched the damn thing.
Yeah,
So
but not all the microwaves could last a lot longer. Like when they take the
well,
microwave apart to get that
it's
magnet.
it's showing that you have the piezo transducer, and the one I have is like the one that has the steel frame around it. So it charged, I guess, the electrostatic charge not only within the transducer itself, but also the steel frame. So the frame of it got charged. But the thing is, it didn't disappear. It held it. It held the capacitive value of the electrostatics in it.
That's
Nothing was
very good to
damaged.
know when working with these.
Yeah, and I proved it not only by 1 week of a charge, I did it again because I'm saying, okay, we got to test this, how long it's going to hold it. So I did the same thing again. I didn't touch it for 2 weeks. Again, the second week came up, I grabbed it again, boom, hit me again.
Oh wow. Did your hat fly off?
No, it was enough to give me a. It's like when you touch the door handle and you get zapped. It was
Oh, like
just
yeah, static electricity.
yeah, it had the electrostatic charge embedded
wow.
in it, and it wouldn't let go of it.
Are you sure it's not in the piezo itself?
Yeah,
And
it
not the
probably
frame?
was. It maybe both. Maybe both.
Because you may have been in a charge cycle where it charged, and it did dissipate, so it stayed in there because that's
Yeah.
what crystal does.
Yeah, it held. It shows that it holds that charge. Yeah.
Yeah, I've seen.
Well-
That's interesting because I just watched a video recently on how certain kinds of like acrylic can do similar things where they hold like an electrostatic charge, and then you can just put a bunch of pressure in one spot and just watch the lightning effect happen within the acrylic. It's really beautiful, actually.
I
But,
saw
And
that.
this kind-
I saw
and
that. They
this-
crack it intentional for
Ye-
yeah, I saw something like
Yeah,
that.
to release the charge. Oh, it's beautiful artwork too. It just produces this amazing pattern.
Now, this kind of goes back to the Floyd Sweet device. And Danny was talking about it, and he made this reference during his presentation that he suspected that the vacuum triode device was electrostatic in nature, almost like an electret.
What barium titanate, right? Is what your
Barium
piezo
titanate.
is.
Yeah, that's the ones I usually use.
Explain to
So-
me what an electret is again.
An electret, it is, it could be made of a bunch of materials. I believe it's polyethylene is a good one. It holds electrostatic charge. So anything that is a dielectric plastic, and if you put certain elements into it, it holds that charge like an
Like beeswax.
electrostatic field. Beeswax is another one. Yeah, mixed up with is it polyethylene? Yeah,
It's
polyethylene.
You know the beanbag chairs, the little balls.
Right.
That's
Yeah.
polyethylene.
Yeah.
Oh, okay.
So it's a mixture of that, beeswax, and a couple other elements. And when it's curing, you hit it with about 20,000 volts, or some people use a lot higher than that. And after it's cured, that electrostatic charge holds, and it doesn't go away.
Well, not necessarily. You have to put it in foil and let it sit for months. And
Yeah, to cure
because
it.
it's got to stay that way. Yeah, but yeah.
Yeah. But the idea of the vacuum triode or the sweet device is kind of similar to almost a piezoelectric effect in there.
Okay, so it depends how you couple it, because some
Yeah.
things spike voltage. So
Mhm.
if you're spiking voltage, then think of it as the center of your capacitor.
Right.
That would be how you want to set this thing up. That way it can do work back and forth to each other, because as it discharges to one, then it discharges to the other. Now you're doing work. Now you're in Floyd Sweet. And there's another device that had two coils in it like this, one on each side, and the guy was able to pull energy in the same way. Basically, he put up an antenna and then grounded it, and he's able to pull it, but it had to do with the mixture with that same element, that barium titanate, in the center
Right.
of it, so that it could do work. And that was your oscillation in the system between the two, and then it would keep building up between the two coils themselves. Yeah, it's in that mixture. It's like bismuth,
Yeah.
when you put it in between two aluminum plates, right?
Right.
It's going to do the same work. It's going to create work for you, so you don't have to do anything. It's the same thing as a meg.
It's like the Casimir effect, like how it creates the energy between two plates, like two electric plates or
But
two metal
you're not,
plates.
yeah, but you're not losing the energy because it's going through the conductor material back and
Right.
forth to each other. Yeah, you're right.
It's trapping the energy. Yeah.
Mhm.
But kind of interesting how all these devices have similarities in the characteristics of the energy and the capacitive value, because a lot of people, when they're making coils, they don't really take into account the capacitive value of a coil. A coil does have capacitive value registered in henries, right? And even back then, this is like before, in Tesla's day, that wasn't really defined yet, so he was figuring all this stuff out before the actual terminology of henries and farads and all this stuff. This Tesla was prior to this, so he had to describe it in the best way he could describe it at that time, which most people had no freaking idea what he was talking about, right? So kind of interesting. I guess we'll move on to Ben, since we haven't seen Ben in forever. So we'll spend a few minutes with Ben and get us up to speed what he's been working on, and yeah.
Awesome. Yeah, we've had a lot of recent developments. Specifically trying to tune the coil, and trying to get the coil, or the extra energy from the coil, to be fed back into the battery. So we did some testing with the oscilloscope a couple days ago, and after drawing out the energy flow, the actual movement of energy from negative to positive, I kind of had a couple of realizations with the system that I'm working with now. And it's pretty incredible if it's actually what's going on. And so we got, the probe grounded across the negative and positive output. So we're monitoring the voltage of the output, and we're getting, on the oscilloscope, we're getting negative 168 volts, and then only positive 10 volts. So this makes complete sense why we're seeing a diminished brightness, and the full potential of the panel, 100% brightness it's getting about 10% bright. So that explains a lot. And when I was drawing out the current flow from negative to positive, I kind of realized, oh shit, this is why they kind of don't want you to learn this. Because when you draw out the flow like that, you kind of realize, oh, we're grounding out the systems in the wrong place in a lot of times. And what I discovered, or what's probably going on in the system, is I'm actually probably already, partially closing the loop and feeding energy back into the battery, most definitely, but it's not in the way I thought. So at the diode, you know how a diode works. You have the anode and the cathode, and in order for it to flow through the diode, you have to have a higher potential at the anode and a lower potential at the cathode. So it's kind of confusing when you're looking at the conventional flow in a circuit diagram or a simulator, and then you're trying to trace the negative. At least it confused me until I had to kind of look at it for a minute. And I realized the diode is actually splitting. The diode is splitting the back and forward EMF. So originally I thought, because we were getting, a resonant pulsed waveform where, you have two waveforms, the back and the forward, kind of chasing each other. I thought that was going into the load and powering the load. No, the diode is splitting that off and feeding the the energy back into the path of least resistance, which is the negative terminal, because I have, early in my experiments, decided it was more efficient to disconnect the input negative and just connect the ground via the negative terminal on the output power rail. And I found that that slows down the battery decay. And this kind of matches up with the theory that if this is true, and it makes logical sense when you look at the circuit. We can look at it in a minute if you want to, but the positive doesn't have any clear return path to the battery. It's the negative that's returning to the battery. And if that's true, then it has to be the synergy between the forward and the backward, creating that bridge, you know, back to the creating the circuit, closing the circuit, as it were. But it's closing it with the back. So it's my theory that we could be, you know, preserving the dipole instead of charging the battery. So we're not really, I don't think we're really charging the battery while we're running the system, but we might be slowing the discharge by kind of feeding that dipole with the back EMF. And this is really interesting. And we had another really great breakthrough today, kind of proving that this, you know, the rodent coil, the APA coils, they really do some remarkable things. Because we had something similar happen in a different setup, the stereo amp setup. If you've remember my Wattman reduction experiment, we've gotten that tuned to reduce by 33 watts, which is extraordinary, by spinning a neodymium sphere in the center of the coil, powered by a stereo amp at about 115, 120 hertz. And this reduces the input requirement, but we were using the wall and a power supply. Tonight, I decided to hook up a 12-volt battery to the system, and what we saw was incredible. So the resting voltage, the stable level voltage without anything hooked up on the battery, was about 12.66 volts. And then we tested the baseline. You know, we turned on the stereo amp, which is, you know, anywhere from 12 to 18 volts max. We turned that on, and then we just turned the frequency up, you know, because that's going to require more draw from the battery to maintain the frequency. So we turned it up to 70, I think 70 hertz, and it was drawing from the battery. The battery went down immediately to 12.45 volts. And then we put the frequency back down, and then we spun the sphere in the center, and we tuned it back up to 70 hertz. And this voltage just jumped back up to 12.53 volts, and it slowly started climbing to 12.55 volts. And I was like, holy crap. Like that. And we let it ran for, like, I didn't want to run it too long because I don't have an ozone detector just in case, but we let it run for a good, you know, like 5-10 minutes. And it was just slowly climbing. It was not degrading at all. I was like, what the heck? It was incredible.
And that's exactly what the Renegade does. It
wow.
removes the demand for any current.
Yeah.
And this goes back to Joseph Newman.
Oh, wow.
He says you don't need current. As long as you got the proper inductor and you pulse that coil at a high voltage, you don't need input current. He was using dead 9-volt batteries. They only had like 7 volts per battery with like less than 10 milliamps of current coming out of those dead batteries. And all he did was daisy chain them all together. He had 84 of them. He got it up to like 300-400 volts, and he was able to move a rotor that weighed 1,800 pounds.
Wow.
Provided you have a large enough inductor. It says the generating power is done in the coil, not from the battery power.
Yeah, from the electromagnetic field.
Right. It's creating the gyroscopic spin of the electrons around the inductor. So if you have a very large inductor, like he says, to get my effect, you need about 200 pounds of copper wire. As soon as you exceed that 200 pounds, you'll see the magic happen. And this is everybody who builds the Newman motor, they're going, where's this excess power? I don't see it. Meanwhile, they got, maybe 800 grams of copper. You're not going to get the effect. You need 200 pounds of coil. Doesn't matter
Wow.
how many windings. Windings are irrelevant. It's mass. If you have enough mass in that coil, you hit it with 400 volts, you're going to get a shitload of power coming back, way exceeding the input voltage.
Does the motor have a sound? Sorry, Nathan.
Well, the commutator makes noise.
Okay.
The arcing, you get the blue spark. So he was finding it was burning up commutator. So he fixed that problem by just adding in a microwave oven capacitor and hooked that up to the inductor. So every time the inductor was spinning on the commutator, it would hit that spot and get that spark. That capacitor from microwave oven would absorb that power. So his commutator wouldn't, self-destruct, basically. That's how he solved that problem. But a lot of people have built the Newman motor, and I've seen a lot of videos of guys doing the Newman motor. It's not that they haven't built the motor correctly. It's the mass of the coil is wrong. You need 200 pounds. He says it in his that's a lot of money, yes. But we're talking about a motor that was made 45 years ago. Right? So it was a lot cheaper back then.
Yeah.
But in a practical aspect, is it really practical to make a motor like that now? Probably not. But it doesn't say that his theory didn't work.
Okay. I have a question for Ben. When you turned it on the first time, then you came back and turned it on, were you conditioning the battery?
Say that again?
You said you turned on your system and it wasn't spiking the voltage. Matter of fact, it dropped it. Then you came back again, turned it on, and it spiked the voltage going back into the battery. Were you conditioning the battery to take the energy the way you wanted to give it to it?
I think that's exactly the way that you can think about what was happening. I think it was conditioning the battery. I can't say for certain because it was only one test that we did. But we'll run it a few more times and see.
Yeah. Well, I can add to that. Bandini talks about this. If you're using a battery that is negatively charged, then that back spike that you're getting that's giving you that effect won't harm the battery. But if the battery you're using was charged on a conventional charger and it's the hot electricity, okay, eventually that battery you're using is going to die. So what you have to do is you have to condition that battery to take a negative voltage. And
we can do that with the Bedini SSG too, yeah. So we can do that and try that too. That's a good idea.
So yeah, because if you have a regular standard battery taking that back spike in the negative or the cold spike, eventually it's going to destroy the battery.
Right.
You're going to wreck the battery. And
But Bedini also said there was a hole in the plates.
Yeah,